Okay, good day everyone. So here's now the third part of the discussion for solving trigonometric equations. So previously in the past two videos, you were able to learn how to solve trigonometric equations that includes a single trigonometric functions using your solving tip number one. And then at the same time, we also discussed about solving tip number two, wherein in a single trigonometric equation rather, we have two or more trigonometric functions involved, or if we have two or more different arguments or angles involved in the equation. So if we have more than one trigonometric function involved, or if we have different arguments involved, then we make use of trigonometric identities in order for us to express our what do you call this express our equation as much as possible to a single trigonometric function, and then from there we just manipulate using tip number one in order to solve for the solution or the fundamental solution set or solution set of our trigonometric equations. So now we move to our discussion of solving tip number three. So here, we use solving tip number three whenever we have equations that contain trigonometric functions of more than one cycle. So what do we mean when a trigonometric function has more than one cycle? So if you remember the standard form of the equation of our trigonometric functions, there is or one of our component, di ba, is B. So if you remember A, B, H, and K, the B there, or the coefficient of the variable X during that time when we discussed trigonometric functions. So the value of B there is actually the number of cycle. All right, it's the number of cycle of your trigonometric function. So that means like if we say we have the equation sine x equals 1, we only have one cycle there because the coefficient of x is 1. If we say we have an equation, let's say cosine 3x equals 1 half, the number of cycles there is 3 because the coefficient of x is 3. All right? So, in cases wherein there are more than one cycle involved, then all we need to do is to solve the variable up to the nth cycle. And what do we mean by that? Instead of just solving for solutions in the interval 0 to 2 pi, except for 2 pi, we extend it to the solutions included in the interval 0 to 2n pi. Again, n is the number of cycle. So, whatever the value of b is, or the coefficient of x is, or the coefficient of your variable is, we just have to substitute that to n so that we'll know up to which, or so that we will know the length of interval that we need to find the solutions in. Okay, so to make that clearer, we're going to have some examples. So if you notice here, our equations also just have a single trigonometric function involved. So that means we will apply tip number one in order for us to solve for 2x. All right. But because here our argument is 2x, we have a value of n here equals 2, meaning we have 2 cycles, then we need to get our solution. Instead of just from 0 to 2 pi, we are going to get our solutions from 0 to 4 pi. Alright? So since n is equal to 2, so that's the coefficient of x, we get solutions in the interval 0 up to 2n pi. But again, take note the value of n is 2. Alright? And if we multiply 2 times 2, we will just get 4. That's why we have 0 to 4 pi. So technically what we'll do here is that we will just get our solution in the first rotation or in the first cycle. So that's technically your FSS, but we will just extend that, okay, up to the second cycle. So how will we do that? So here, using solving tip number 1, we can easily solve for 2x. Okay? So our variable or our angle here is 2x. So when is sine equal to 1? So sine is equal to 1 whenever our angle is pi over 2. So we put there pi over 2. Okay? And pi over 2, that is the only solution that we have from 0 to 2 pi. Okay? But then we have to extend it to another cycle. Okay? We have to extend it up to 2 cycles. Meaning, we will also need to get the angle from 2 pi up to 4 pi. And how will we do that? All we need to do is to just add 2 pi, okay, to our first solution. So we will just add 2 pi to our second solution so that we can extend our solution up to the second cycle. Alright? So that we can extend our solution up to our second cycle, which is up to 4 pi. Okay? So if we add pi over 2 plus 2 pi, we are going to get 5 pi over 2. We will get 5 pi over 2. So these two are the solutions to this equation. But then, again, when we want to find the fundamental solution set, then that means our answers or the answers must be angles that are from 0 up to 2 pi except for 2 pi. But we know that because 5 pi over 2 is in the second cycle, then this must be more than 2 pi. So how are we going to bring this solution or these solutions back to the first cycle or back to 0 to 2 pi? All we need to do now is to just look at this. We have a coefficient of 2 here. So in order for us to find the solution set, all we need to do is to divide or to multiply both sides by 1/2. So if we do that, so 1/2 times 2x will just be x. And then 1/2 times pi over 2, that will be pi over 4. And then 5 pi over 2 times 1/2, we get 5 pi over 4. So technically, we just multiplied 1/2 to everything so that we will just get the value of x, which is or which are the values or elements of our fundamental solution set. So base here, our fundamental solution set will be the set containing pi over 4 and 5 pi over 4. And that's it. So take note again, if we want to get now the solution set, so if we wish to get the solution set, then all we need to do is that from the FSS, we just need to add 2 n pi or 2 pi n. Sorry, this is plus. Okay, plus 2 pi n, where n is an integer. Okay? So again, if we want the solution set, we're not just getting the answers within 2 cycles. We want to get the answers within the set of real numbers. All right? So let's put this back again to the original question. So again, our answers will just be pi over 4 and 5 pi over 4. Okay? So let's try another example. So here we want to solve for the fundamental solution set of tangent 3 theta equals -1. So here we note that, so our variable here is theta. It has a coefficient of 3. So that means n is equal to 3. So since we have n equals 3, then it means that our solutions must be what? So our desired solutions are in the interval 0 up to, so 2 pi, 4 pi, 6 pi. So we have 3 rotations or 3 cycles. Okay? And then from here, we just need to solve. I think this is very straightforward. So from here, we know that 3 theta must be equal to what? When is tangent equal to -1? So tangent is negative in the second and fourth quadrant. All right? And we know that tangent is equal to 1 when our angle is pi over 4. But pi over 4 is a reference angle. It's in the first quadrant. We want to get the angle in the second quadrant. So that means we have pi minus our reference angle, which is pi over 4. And in the fourth quadrant rather, so let's just put this in quadrant 2. And then for quadrant 4, where tangent is also negative, so we have 2 pi minus a reference angle pi over 4. Again, why did we choose pi over 4 as a reference angle? Because tangent is equal to 1 when our angle is pi over 4. Okay? So these are your answers in the interval 0 to 2 pi. So now we just simplify this. So pi minus pi over 4 is just 3 pi over 4. So we know that that is in quadrant 2. And then for quadrant 4, we have 2 pi minus pi over 4. So we get 7 pi over 4. And that's our angle in quadrant 4. So again, this is just in the first cycle. So now we get the angles in the second cycle. So how will we do that? So just like what we did a while ago, we will just add 2 pi so that we can get the second cycle. Okay? So let's just change this to color red. So you know that these are the angles for the second cycle. So 3 pi over 4 plus 2 pi, we will get 11 pi over 4. And then 7 pi over 4 plus 2 pi, we will get 15 pi over 4. Okay? So these two are our answers for the second quadrant, second cycle rather. And now we get our answer in the third cycle. So how are we going to get the angles in the third cycle? So technically, you just make use of your second cycle angles. And then, just like what we did a while ago, we will just add 2 pi. So plus 2 pi. And then we simplify. So 11 pi over 4 plus 2 pi, we will get 19 pi over 4. And then 15 pi over 4 plus 2 pi, we will get 23 pi over 4. Okay? And these are now your answers from 0 to 6 pi. So the black one, this one, is from 0 to 2 pi. And then the red one would be from 2 pi to 4 pi. And then the blue one would be from 4 pi to 6 pi. Okay? But then again, these are not yet your final answer. We have to still divide everything by 3 or multiply everything by 1/3. So if we do that, our theta will now be what? So 3 pi over 4 times 1/3, we will get pi over 4. 7 pi over 4 times 1/3, we will get 7 pi over 12. And we will just continue the process. So 11 pi over 4 times 1/3 is 11 pi over 12. And then 15 pi over 4 times 1/3 is 5 pi over 4. 19 pi over 4 times 1/3 is 19 pi over 12. And finally, 23 pi over 4 times 1/3 is 23 pi over 12. Okay? And these are now your final answers. So the answers that you'll get here are actually your or elements for your FSS or fundamental solution set. All right? So I hope that is clear. So let's have one final example. So we have here cosine 2x equals negative 1/3. So again, so let's just simplify the solution. N is equal to 2. So we need solutions in 0 to, since we just need 2 cycles, so 4 pi. Okay, so now with this one, so we have 2x is equal to, so again, we don't have a special angle that will give us a value of 1/3. So using our inverse circular function or inverse trig function, so this would be our cos of negative 1/3. And we know that when we have our cosine as our inverse trig function and our argument is negative, it follows that this is in quadrant 2. Okay? So that means our arc cosine is negative. But take note, other than in quadrant 2, where is cos cosine negative as well? So we know that the answer there is, of course, quadrant 3. Okay? So cosine is also negative on the third quadrant. So how are we going to get the angle in the third quadrant? So now, so let's just have some side notes. So gawa tayo ng maliit na side note here. Side note. Okay? So the reference angle of our cos negative x, okay? Hindi pala. Ulitin natin. So the reference angle, oops, it's already off the screen. of r cos negative x is simply its first quadrant counterpart. So that means, remember from the definition of our cosine function, the negative one is in the second quadrant and the one in the first quadrant is the positive part. So that means our given our cos of negative x, our reference angle is equal to the arc cos of x. So technically, for the reference angle, we just need to remove the negative sign. So it follows from this side note, all right, that, so lagyan na lang natin, it follows from the side note that our reference angle is equal to arc cos of 1/3. So following this, okay, so we can easily solve now for our angles. So take note, remember, balikan natin to. And I'll just remove this. So this is less than 0. So, the less than 0 yan, ang cosine, then that means 2x must be in quadrant 2 or quadrant 3 because these are the quadrants where your cosine is negative. So now that we know our reference angle, we can now easily solve for the value of 2x. So 2x is equal to, in the second quadrant, that would be pi minus arc cos 1/3. Okay, and in the third quadrant, that would be pi plus arc cos 1/3. Okay, so I hope you can still follow. So let's now continue. So again, these are the values of 2x. We need the value of x only. Okay, so that means we have to divide by 2. But yes, before that, I forgot. Let's just go back to the previous slides. We want the solution from 0 to 4 pi. So that means these two are just your solutions for the first cycle. Okay? We still need to get the solutions for the second cycle. So for the second cycle, so I'm just putting it here under so it will just not confuse you. So for the second cycle, so if we add 2 pi here, so that will just become 3 pi minus arc cos 1/3. And then for this one, if we add 2 pi here, so because pi and 2 pi are like terms, so we just add them. So we will be having 3 pi plus arc cos 1/3. And these two are for the second cycle. Okay? So now that we have our solutions in the first and second cycle, we now solve for the value of x. So in solving for the value of x, again, we will just have to divide each of these solutions by 2 or multiply each of these solutions by 1/2. So if we do that, So we just have, so pi minus r cos 1/3 times 1/2. We will be having pi over 2 minus 1/2 r cos 1/3. Okay? Or another way, if you don't want to get confused, then you can just do pi minus r cos 1/3 divided by 2. So that is okay. And then, for the second solution, so sa pangalawa, for this one, we divide this by 2. So, pi plus r cos 1/3 divided by 2, or all over 2. And then, for the third solution, oops, you can just do the same thing. But this time around, magiging 3 pi minus r cos 1/3 all over 2. And then, finally, the last solution, so magiging 3 pi plus r cos 1/3 all over 2. Alright? And since we already divided everything by 2 and this is just x, so this is actually our fundamental solution set. And that's it. Alright? So, with that, we're going to end this portion of the discussion. Please try to answer this, where is it? Let's try to answer these try exercises, and I will be giving you a solution sheet for this one that I'm going to upload in our Google site. So thank you and see you on our next discussion.